Hello and good afternoon, everybody, and welcome to this new session. Today's session will be about machining, an important chapter in the curriculum of mechanical engineering students. In addition to my official job as a teacher of English language and literature at the Department of English Faculty of Letters in Shop, it is no secret that I equally teach at the ENSEM School of Engineering in Casablanca, Hassan II University, and have been doing so since 2007. And believe me, it is more of a passion for this beautiful language and this profession than sheer moonlighting. Were it not for the COVID-19 pandemic and lockdown and subsequent distant learning, you would not perhaps see this recording, as all classes would have been dispensed on site. The course objective for the second year mechanical engineering class are the following. We could sum them into 3 points. Number 1, to consolidate the students' mastery of the basic language structures. That means grammar. We have done some grammar previously. I have sent some handouts, and I think that would be more than enough. Second objective is the acquisition of technical vocabulary related to mechanical engineering. As you know, English is one language as a whole, but we could divide it to be able to master parts of it. And that's where SP, English for specific purposes, comes in. So you are supposed to acquire technical vocabulary related to mechanical engineering because in the future, probably, you will have to talk about machines, to colleagues, to customers, to foreign partners, etc. So you need to know this type of vocabulary in addition to the general English vocabulary that we teach and learn every day. Number 3, that's the last objective, is to develop oral and written communication skills as many as may be needed in a professional context. Yes, we shall try, we have been trying to develop our oral and written communication skills in order to be able to write or to speak, to hold a conversation, and to write an intelligible essay or email or letter or article or presentation. This is what you will need to do professionally in the future. And these are the objectives that we are trying to meet through these courses. I have already administered 2 or 3 chapters distance learning. One about the basic technical vocabulary and grammar, especially about the vocabulary concerning all the tools or the toolkit of an engineer, the tools that are used by a technician or an engineer, and that we need to know. We need to know everything, actually. When you learn a language, you need to know all its vocabulary. You are not there to bargain. You have to learn all the vocabulary that is there. Probably the nearest to you, the better. And you should learn whatever vocabulary comes your way. So the basic technical vocabulary and grammar, some tenses, some adjectives and adverbs, prepositions, etc. I sent you a chapter on materials technology and material types, different minerals, ferrous and non-ferrous materials, polymers, etc. I sent you also through Google Classroom a chapter about measurements, how to measure, and different units of distance, of time, of power, etc. Now I would like to present three more chapters very briefly. Don't worry, you will not be overloaded. I am particularly aware of that. Uh, yes, one more chapter about material types, and I will leave it until later. And a second one on machining. This is today's session. And a last one, or penultimate one, on engines and motors. I know many of you are very passionate about automobiles and cars. All young people are, and not so young as well. And therefore, we should be talking about engines and motors uh, and vocabulary related to them. And finally, the last chapter, but not least, will be about transmission. Of course, there are many more, much more chapters that need to be studied. I will send you the book, the PDF, and I hope you will do some self-study by yourselves. The exam will be 1 hour and a half of multiple choice questions, about 40 questions. That will not kill you. You'll have just to choose to rake your brains a little bit and to choose is it A or B or C or D. So it will be easy. The COVID-19 has been lenient with you, hasn't it? So about 40 questions plus a little writing. And let me just hint here that you will have to write kind of essay or a short essay or short passage in which you use much of the vocabulary that we are learning here. You will remember it, and I'm sure it will turn out handy. So let's proceed. Machining and CNC. CNC means computer numerical control. What is machining? Machining is the use of machines to cut pieces of material. C'est ce qu'on appelle usinage en français. And those cut pieces of material are called work pieces. So remember these words: machining, usinage, work pieces, to shape them into components. So you are creating components that you will be placing elsewhere, that will be playing a role somewhere else, that will be useful for other purposes. The tools used in machining to make holes, grooves, les rainures, les sillons, threads. So you can make lots of things with machines out of work pieces or out of big pieces of material. Grooves, ce sont des sillons, holes, ce sont des trous, and threads, ce sont des fils, etc. So these machines are called machine tools. Metal is often machined, so the verb to machine. There is the noun machine, but the verb machining exists as well, and it can be conjugated in the various tenses. As it is cut, waste is produced, and that waste is called swarf or chips. Chips of wood, but it could be chips of metal as well. Donc en français, on appelle ça les copeaux. During machining, a liquid called cutting fluid may be pumped onto the workpiece to act as a coolant. Yes, we need a coolant when we are working, when we are machining materials and cutting pieces of material. We need a coolant because often heat is used. Most of these machining pieces of equipment or tools use heat or high voltage electricity, as we shall see later. So we need to keep the workpiece cool. In manufacturing, machining is usually guided by computers. Well, it's different from the past. In the past, craftsmen, technicians worked in their workshops. So it was more than a craft and a science, than a technology. But nowadays, computers are used, and that's why we we use the term computer numerical control systems, CNC in short. Often design information on shapes and sizes of components is fed directly into CNC systems from computer-aided design or computer-aided manufacturing, CAD or CAM software. Machining with cutting tools. Now let's see the various types of machining and the various types of cutting tools. Below are the most common machining techniques which use cutting tools. Milling, c'est l'équivalent de fraisage, is cutting done by a milling machine. Milling machine, c'est une fraiseuse, which is often used, or which often uses toothed cutting discs or wheels with teeth that have sharp edges. When a workpiece is milled, it is held in a fixed position on the machine and is shaped by cutting tools which rotate, which spin while being moved over the surface of the workpiece. By the way, in the past, المخشبة, or the place where wood is cut, is called wood mill. But of course, here milling could be used for metals. So milling can be used for metals as it used to be for wood. So a piece is held in a fixed position on the machine, and a cutting disc goes through it. There is also another system or another technique which is turning. Turning is a technique for cutting components to have a circular that have circular cross section. The workpiece is turned by a machine called a lathe, which rotates the workpiece, which means it's the workpiece which rotates while the cutting edge is fixed. It's the opposite of milling. Well, the purpose may be the same, but the method is different. Milling can cut maybe straight objects, but turning has to do with with circular objects. This is a milling machine, a bench top. It has a bench. C'est comme un banc. Bench top mill drill. So it mills but also drills. This one has is multivalent. It has different purposes. This machine, it's Chinese made, with power feed and tapping. So as you can see, there is a nozzle over there, which can hold the drilling piece or the drilling bit. This is a lathe. To the left is a big size lathe, whereas the one on the right is a small size for high precision turning. Yes, this is a lathe machine at work. As you can see, the object or the workpiece is circular and it turns, and the cutting bit is fixed. These are sources for the pictures that I found on the internet. Turning using a lathe, as you can see, it's the same process as before. As you can see, the chips which are cut from the metal to create and to shape the object to the right measurements. Now the next machining device or system is sewing. This is a very old thing. Sewing used to be by carpenters. Sewing, coupe à la scie, is cutting using a blade, a thin, sharp piece of metal, which usually has teeth, to remove a thickness of material slightly wider than the blade. Exactly. This is what a saw does, especially when you cut wood. So it could be used also to cut metal. So you saw with a blade that has teeth to cut. The gap left by the blade along the line of the cut is called a kerf. نعم. The gap left by the blade along the line of the cut is called a kerf. So that's the line that is left by the saw. So remember that word, the kerf. Machines that use the blades include circular saws, as we shall see in a picture in a moment, which have rotating circular blades. And there are band saws and power hack saws. A hacksaw, c'est une scie à métaux, has a blade with very small teeth for cutting metal. Saws may also use abrasive wheels, that is, thin, circular cutting wheels with rough, hard surfaces, often made of industrial diamond. We shall explain that in a moment. So as you can see here, this is a saw disc blade made in China, as you can see from the inscription. And this is a hacksaw to cut metal. It's a saw with a blade with very small teeth, but quite hard. This is a circular abrasive diamond cutting disc for rock cutting. As you know, diamond is the hardest material, one of the hardest materials, I would say, and therefore small pieces or dust of diamond is used in abrasive tools, abrasive circular discs or abrasive discs, cutting discs, to cut things which are very hard, like granite, for example, like granite. This is a band saw, as you can see. Now let's move to the next machining activity, which is drilling. To drill means to make a hole in a piece of material or in stone or somewhere. Drilling is a technique for cutting circular holes. A machine called a drill is fitted with a tool called drill bit. So it's the head of the drill is called the drill bit, which you can change to obtain the appropriate size. The bit rotates and drills into the material. You can do that in wood as much as you can do it in wood, in metal, as well as in stone or in the ground, if you are looking for petroleum, for example. Holes with large diameters can be cut using hole saws. Hole cylinders with teeth, that's for petroleum, which saw circular cuts and remove a core, a solid cylinder of material. This is what happens when drilling for petroleum. When used to drill into concrete, this technique is also called core drilling. Yes, maybe sometimes you need to drill into concrete to, especially in demolition, to use dynamite to explode the big pieces. You have to drill somewhere where you could insert the explosive. As the hole saws have industrial diamond edges. Usually, drilling refers to making new holes. In machining, enlarging a hole to make it wider is called boring. So this is a new verb maybe which you didn't know before. To bore a hole is to make it bigger. And finally, the last drilling technique here is grinding. Grinding هي طحن يطحن is removing material across a surface area using abrasive wheels. So you can remove a layer of material from a surface. The machines used to grind material with abrasive wheels are called grinders. So all these words we need to know. So the first one, the yellow one in the picture, is a Stanley power drill. As you can see, it has a battery of itself. You can see here the head piece or the drilling bit. The drilling bit. This one is a heavy-duty and variable speed reversible hammer drill. This is a more sophisticated one. It's heavy-duty, so it's not for home. It's professional. It's more professional. It is. It has different speeds, and it has a hammer drill. It hits as well. It's a Bauer. It's German made. These are different drilling bits. This is a core drill bit, which can remove the internal part to make a space for a tube, for when drilling for water or drilling for petroleum. This is a core drilling bit again. This is with three heads, as you can see, three turning heads used in petroleum as well. So these are, as you can see, drilling bits. This is a picture of the core drill bit. This is a grinder to grind surface of a piece of material. Now there is another system which is called guillotining. Guillotine. It's cutting the heads of criminals during revolutions, as in the French Revolution. But it is a term borrowed and used in mechanical engineering as well. Guillotining is when thin material is cut by applying pressure in order to shear them, that is, to cut them with scissoring force. A shear is a big piece of couple of scissors. Shear. Les grands ciseaux, les cisailles. You can use a shear to cut the wool of shearing the wool of lambs. كان يجزوا الأغنام. The same thing. You can use that to prune your hedge, for example, the hedge of a garden. You can use shears. However, the force used in guillotining is called shear force. Shear, S-H-E-R-E-A-R. S-H-E-A-R. Sheets of metal can be sheared, especially when you have sheets of metal when you want to make a door, or you want to make to cut a big surface, a sheet using machines called guillotine, which has a long blade. It has a long blade. Usually, sheets are guillotined when long straight cuts are required, especially when you need to cut in a long shape, not in angular shapes or circular shapes. Shears work better when you are cutting sheets of metal. This is a diagram which shows that. So the guillotine happens like this, as you can see in white here. You can see the cursor. So the blade falls. There is a weight, a falling weight. There is a pressure weight against this block in here, which is stable. And of course, it cuts the sheet of metal. That's guillotining. Now let's move quickly to punching. Small shapes such as circles can be sheared from sheets using a machine called a punch. Punch, c'est un coup de poing, généralement. But in this case, punching means to cut a small shape from a sheet of metal using a machine which pushes a die, a shaped tool in a specific shape. Just as when you are making cakes, when you are making cakes or biscuits or something like that, you can use a die through the sheet. The shaped piece of metal that is punched from the sheet is called a blank. So what we get ultimately is a blank. We push a die and we get a blank. If the blank is the finished product, the process is called blanking. Oh yes, punching, blanking. If the sheet itself with holes made in it is the finished product, the process is called piercing. Now, nothing to do with the piercing that some women, some men perhaps, also use in their faces, in their ears and lips and noses. No, this is about metals. So piercing, blanking and piercing and punching. So when we cut small shapes using a die, that's called punching. And the end product is called a blank. If the blank is a finished product, it's called blanking. Of course, if you are making a decorated door for your house, you could use the technique of blanking or a piercing. So here is a diagram showing the punch. There is a sheet of metal here in white, and this is a die, and this is the cut piece is called a blank. High temperature metal cutting techniques. So here in the previous cases we have seen the use of force as a means of like shearing, force or punching as means of cutting metal, of machining workpieces. However, we can use high temperature metal cutting techniques. The first of them is flame cutting, where generally oxygen and acetylene are used. The two gases, oxygen in one bottle and acetylene prepared in another bottle, they are blown through a torch. A torch, Michel, basically a tube. That torch comes from a tube, as a mixture called oxyacetylene, and the acetylene burns in the oxygen. Of course, the oxygen encourages the burning of the acetylene, and it there is a strong power, high temperature flame which burns and which cuts. To produce a flame hot enough to melt metal, of course, you melt the edges to cut. So this is flame cutting. As you can see, this is the workpiece. This is the nozzle, which brings oxygen and acetylene mixture with a flame torch. This is the torch, and which cuts from this piece of metal. This is another example. As you can see, it's industrial. It's not artisanal. It's not handicraft. It's more professional. As you can see, you can cut a shape into a thick metal using flame cutting. This is a workman using a torch of oxygen and acetylene to cut metal. The principle is explained here. Oxygen in the middle, fuel, gas, and oxygen in the other two sides, acetylene, of course, and the heated flame, and the metal melts in the middle where it is cut. Electrical discharge machining, as you can see, EDM, electrical discharge machining. So we can use electricity on an electrical discharge to cut pieces of metal. It is also called spark erosion. So there is a spark, an electrical spark, c'est l'étincelle, l'érosion par étincelle, involves passing a tight length of wire through a workpiece, similar to the way thin wire is used to cut cheese. Well, this is a good comparison. You know, some people can cut cheese using a wire. There is a tool which can cut and make an even line through cheese. Especially if you have a big ball of cheese, you can cut it using that piece of equipment. So it's the same principle here. However, the wire does not actually touch the workpiece because electricity is used here. It's the spark which does the job, not the wire. Instead, a high voltage current produces an electric arc which jumps across a small gap between the wire and the workpiece. So there is some space between the wire and the workpiece. So it's electricity which does the cutting. As the current arcs, it generates heat which melts the metal ahead of the wire. Ahead, ça veut dire devant. Ahead of the wire. So electrical discharging, as you can see here, this is a diagram, it's a schematic diagram, graphite or copper electrode cathode. So the head is a cathode. It brings the electricity. Notice that there is a liquid in this here. The workpiece is the workpiece. This is the workpiece, which is used as an anode itself. Is put in a liquid. So the liquid is necessary here. Flushing nozzle. So there is a nozzle which flushes, and of course the spark cuts into the workpiece to cut it ultimately. As you can see here, there is a gap between the cathode and the metal being cut. It's the heat. It's the heat produced by the spark which cuts through the workpiece. Dielectric fluid, kerosene tank. As you can see, there is a liquid here. The workpiece is probably copper below, and this is the the cathode. What are the advantages of electric discharge cutting, electric discharge machining? It does not depend on mechanical properties of workpiece. So it's the electricity is just the whole job. No forces are acting on workpiece, so no residual stresses are present in the workpiece. The surface finish produced will be better, so it's better quality. The edge is better. The highest material removal rate. This disadvantage is workpiece must be electrically conductive. Well, if it's not conductive, you cannot work on it. So this is the drawback, the disadvantage. This technique, electric discharge machining, can be used when producing holes in dies or die shrinking. The use for producing holes in hydraulic and pneumatic valves, using for producing holes in air brakes, and use for producing size less than 0.1 millimeters. So it has a number of purposes. There are different techniques of machining, and each one is used to achieve the best results depending on the material and the purpose for which it is used. We can use also plasma for cutting. Plasma cutting, this is another device. The use is plasma torch. There is a different torch. Not like the previous one, not the oxygen and acetylene torch, but this is a plasma torch to blow out gas at a high pressure. At high pressure. Oh, yes. And the gas is argon. Now, argon, I thought that argon was a very expensive and rare gas. I hope I'm not wrong. But still, it is used in certain cases for plasma cutting. So argon or other gases, but probably argon is the most suitable one. At the same time, a high voltage current is passed through the plasma torch and arcs between the torch and the workpiece. So probably this is a more sophisticated device. So it's different from the electric spark used in the previous. Here we are using plasma as well. So this ionizes some of the atoms in the gas, changing it to plasma as the plasma is heated by the arc, which is a luminous electrical discharge between two electrodes or other points. It reaches an extremely high temperature. Probably this technique is used with very hard materials. Much hotter than would be possible for a gas that had not been ionized. So here the novelty here, or the addition here, is the ionization. We know that when atoms are ionized, the electrons, tiny negatively charged particles that are normally attached to the atom, they break away and float freely within the gas. You know this from your chemistry classes. This is a plasma cutter. As you can see, that nozzle. So there is electricity plus a gas, argon, and there is an ionization which creates an extremely hot temperature which can cut through the workpiece. The principle of plasma cutting, as I explained just now, the electrode in the middle. There is a cooling water around because high temperature, we need to cool the system, the power source, and the arc. And as you can see, the flame which cuts through the workpiece. Now let's move to laser cutting. Laser beams, they are concentrated light. They can cut materials accurately in small quantities by melting them. Laser cutting is especially suitable for plastics. I know you know these things, but we need to speak about them in English. So I will expect you in your essay to speak to me about these things in English accurately without any mistakes and quite fluently. This is what I anticipate. This is what I expect. So laser beams are concentrated light. So it can cut materials accurately, probably more accurately than any of the previous techniques or devices, uh, and in small quantities or in small size by melting them. Laser cutting is especially suitable for plastics, so polymers and plastics. This is how a laser beam works, cutting through um, through a workpiece. It must be very accurate. How does the laser work? So you can 100% reflect in mirror. There are a number of mirrors. There are flash lamps on all sides. As you can see, the arrows of reflection of the light. Laser discharge tube. This is the laser discharge tube. Single wavelength in phase light. And there is a lens in here which does the job, which converges the rays. These parallel rays are converged into one point. So the focal length. So it focuses the various rays and at a specific point on the workpiece and which cuts it. The same thing as above. So the beam, the faisceau, the beam bender, the laser resonator. So there is a focus there, and there is a nozzle, and the beam goes through the workpiece and cuts it even. It cuts it even. There is a final technique of cutting, of machining, using ultra-high pressure water jets. Yes, water can be used to cut materials, especially if used through ultra-high pressure. If subjected to ultra-high pressure using certain pumps and certain pieces of equipment. Donc, ça se traduit un jet d'eau à ultra haute pression. Look, in English, the head noun is left towards the end. Water jet. What jet? It's a water jet. It's a pressure water jet. It's a high pressure water jet. It's an ultra high pressure water jet. So each of these words in this noun phrase adds extra meaning to the noun phrase or to the head noun. It modifies even further the head noun. So jets of water are fired at extremely high pressure. Look at that adverb, extremely high pressure, an adverb modifying an adjective. An extremely high pressure, an adverb modifying an adjective high, because adverbs modify adjectives, verbs, adjectives, and other adverbs as well. So they can cut almost any material, almost any material. So this is the ultimate technology in cutting, in machining, isn't it? Ultra high pressure water jets, including metal. An advantage of ultra high pressure water jet cutting is that the edge quality of the workpieces is high. That is, the cut edges are smooth, probably the smoothest among the previous kinds of cutting. This means that no secondary operations are needed. Further processes to smooth rough edges are required. Um, so because ultra high pressure water jets are cold, they do not leave a heat affected zone. Exactly. This is not, it doesn't require heat. So it doesn't leave any traces on the workpiece, an area near the cut edge whose properties have been charged by heat. So this is a water jet piece of equipment. As you can see, a nozzle there. So it uses basically water, but subjected to high pressure. This is a robot, a high pressure water jet robot, and this is the head piece working. As you can see here, there is a motor, and there is an oil circuit plus water circuit. So it's the oil which helps produce the pressure for the water to achieve that high pressure. So there is a pump and two cylinders, one for oil and one for water, and the pressure is translated from the oil, is transmitted from the oil to the water. These are the sources. Thank you very much. I expect you to do the exercises associated with this chapter. Just a couple of pages. So please try to do them. I hope you will find them enjoyable and enriching. And thank you very much for your attention. See you later.